So, yes, your notes today look similar to the ones you guys had last class. This is the second half of your 7.6 notes. Okay? So it'll assemble the same way. It's another flip book. It'll assemble just like you did the last one. But this time we're going to be covering logarithmic equations, not exponential equations. And then when we get to the end of the lesson, it'll be a combination. So we're going to put everything all together that you've learned in 7.6. Okay? Does that sound like that?
Yeah. That girl was so straight up, but no.
No. Very
tired.
So the initial notes should go pretty quickly. And then we've got a little bit of something that have you guys do to kind of get up and make sure that we're understanding everything. And then when I see you guys on Monday, remember we're testing next Wednesday. Did you guys get a test review copy? Y'all should have picked one up last class.
Oh.
If you picked one up last class, then you shouldn't need another one. Is that an extra, Jonah? You mind giving that one to Sean? Thanks, dear. So Sean, we do have our first test next Wednesday. I'll kind of work with you to make sure you're all caught up and ready to go as far as that's concerned. But you can use the test review on the test. So make sure that you guys are making notes, doing whatever you need to do so that you're prepared and ready to go for the test next Wednesday. Monday of next week will be review day. So we've got a couple of activities planned for you guys on Monday to make sure we're ready to go for the test. Yes or yes?
Yeah.
Y'all ready to do that? Okay. One thing. Your 7.6 homework. We started on it last class. Told you guys it wasn't due until next class, right? We noticed there was one problem, so make a note somewhere, wherever it is that you're taking your mental notes to do your homework. Number 35 on your homework for tonight. On number 35, you will have to solve that one using a calculator. So we'll show you how to do that here in just a little bit. All the other ones you need to solve algebraically, and then you can check using a calculator. But number 35, you will have to solve using a calculator. We're not going to require you to solve that one algebraically. And you have one similar to that in your notes today. Everybody good? So make a note wherever you need to make a note that number 35 is okay to solve with a calculator. So good? Good? Everybody got a calculator? Because you're going to need them for today. All right, let's do this, y'all.
How are y'all?
How's lunch? What did y'all eat? Chick-fil-A? Yeah, Chick-fil-A in the cafeteria? Ooh, that's too nice. I forgot my lunch. Hee. I ate hot Cheetos.
Oh, that sounds good.
Honestly, the baked hot Cheetos, in my opinion, are the best hot Cheetos. I don't know about. No, the baked ones on the.
I like mine helps.
You want to keep them fried, huh?
You know, if I'm ready to eat the bad, might as well go for work.
Alrighty, so, anywho, you got this packet here. It's another foldable. So, separate the pages. We're going to focus on the one that says, can you see that? The solving logarithmic equations. So this is going to be face up. You're going to want to fold it as so. So you got rewriting log equations on top and then solving logarithmic equations on the bottom. Fold it. So, rewriting log, that's the one on the top. Solving logarithmic, that's the one on the bottom. Next, we're gonna get the second page, have the one with all the problems face up. It says solving exponential and log equations on the bottom. Get the folded paper and then put it on top of it, like so. And then we're going to fold where the crease is. And voila. That should be your end product right there. So, hopefully you guys read the board. Or you guys supposed to get 2 pieces of tape. Did everyone has 2 pieces of tape? Let me see. Everyone's got tape? Tape. Cool. Alrighty. So what we're gonna do with the tape, so we're gonna go flip it to the first page, and you see where that little crease is in the middle. You're gonna get 1 piece of tape, and then tape the pages together, like that. And then for the second piece of tape, we're gonna flip to the last page, the one that has the 1 through 8, and then place the tape in the middle, like so. So now we can flip the foldables and they won't fall apart. Feelings? You guys okay? Yeah? Alright. So today we're going to be learning about solving logarithmic equations. So a quick review over last class. How do I solve an exponential equation? Cool. And what do I do with the base and stuff? I switch or rewrite the exponential into a what? I rewrite the exponential into something. A logarithmic. So that's for solving exponential equations. So what do you think we're supposed to do with the logarithmic equations? Yep, that's basically the big idea. Just rewriting stuff. So quick review. Let's go on to the first page. Rewriting the exponential equations into logs. So number 1, how would I rewrite number 1 as a log?
Log 10, 100, 2.
Cool. Do I need to write the 10?
No.
Nah. Yeah, it's the common log. Ooh. Cool. What about for number 2? 32. I think it's 5. Cool. Now, number 3, that's supposed to be a square root symbol. So how would I rewrite this as a log? Well, we know it's going to be a log, so we need that log. What's my base in this equation? Is anything being raised to something? No. Well, this is a square root, right? How do I raise? Yeah, it's 25. My base is going to be 25. So what's my argument? 5. And what's my exponent? 2? Well, if I write a 2, that means that 25 raised to the 2 gives me a 5.
Oh. 1/5?
3. 1/2.
1/2. Let's go. So the square root can be written as the exponent 1/2. You guys remember from 2-3 weeks ago? And if we move on to number 4, how to write that as a log? Log 11. What's my argument?
120.
Yep, 1/121. And that is equal to? -2. Cool. So, something slight? Something slight, let's go. So, if we continue on, it asks us what the log equality property is. Do you guys remember from 7.5 what the log equality property is?
Is that just the, it's like 2x and equals 2y, if x and y is the same?
That's pretty much the idea, yeah. So if you got a log with a base x, and that's an equal to a log, I don't see that here, base y. So this statement is going to be true if x is equal to, what does my x have to equal in order for these two logs to be exactly the same? Yeah. So it's basically the same as the exponential equality one from last time. And for the exponential equality, if my bases were the same, what was my new equation that I used?
What is the symbol right in front of that?
This?
If.
Yeah, that's an if. That's an
Oh.
IF.
Ow.
Not bad.
It's one of those special math symbols.
I didn't know it. That's the alphabet in this thing.
Yeah, so like for the exponential equality, if like the bases were the same, we rewrote the equation, but without the bases, right? We just wrote the exponents because the bases were the same. So for the logs, basically the same idea, since the bases are the same, we're just gonna rewrite what the argument is. So the x equals y. So for number 5, are my bases gonna be the same? So I'll just rewrite it just with my arguments. 3x minus 8 is equal to x plus 6. And then we solve for x. So how would I solve for x? Add 8. Three x is equal to x plus. What's 6 plus 8? 14.
So you put the x on the x plus 14 on the subtract.
Almost subtracted x from both sides. Yep. Like that. I should be left with 2x is equal to 14. Meaning, what is my x?
7.
Yeah. Cool. So if you got two logs being equal to each other and they have the same base, we can use a log equality property. So for number 6, would we use the property?
Yeah.
Yeah. What are my base?
Mm.
Yeah. So what's going to be my equation that I'm going to be working with? Yep. And then we just solve for x. So how do I solve for x? Add 2. I got 9x is equal to 4x plus 5.
And subtracting 4x from both sides.
So now I got 5x is equal to 5. So what's my x? Yeah.
So you don't do anything with the basic figure, like you don't put that in equation.
No,
Just
sir.
only if they match, that's when you use the property.
Yes, sir. If my bases are the same, we can just basically just focus on the arguments. Cool. Any questions, concerns? So, a log being equal to a log, this is one type of equations that you're going to use, or see. Another type are the ones on the next page, where we only have one log, and that's being equal to a number. So whenever you have equations like these, you're going to follow these 3 steps. The first one, of course, is isolating the log expression. So for number 1, what is my log expression? That's part of it. That's my argument. Yeah. So you want to get this by itself.
That's already by itself, no?
It is already by itself. So we go to step 2, which is rewriting the equation into an exponential form. So how would I rewrite this as an exponential?
X squared.
Well, what's my base?
2.
Yeah. That's a 2. What's going to be my exponent? It's going to be a -1. And then that's going to equal to x plus 5. Do you guys know what 2 to the -1 is equal to? Yes, sir. 1/2. So 1/2 is equal to x plus 5. And now we solve for x. So what do I do with that 5? Subtract 5. And what's 1/2 minus 5? Negative. -4.5, yeah. Cool beans. All right, so let's move on to number 2. Is my log isolated? Yeah. What is it?
2x, or 2x.
Yeah, I want 2x right there. So now I gotta rewrite this as an exponential. What's my base? Yeah. And what's gonna be my exponent? Yeah. And what is that equal to?
2x.
2x. So it's gonna equal whatever my argument is. So 2x, 2x. Kind of like how x plus 5 does x plus 5. Now, if I raise e to the 1/3, is that gonna give me a pretty number? Nah. and like big ideas, because when you get big numbers, you're gonna want to like round, right? Yeah, big idea is more like the most accurate number that you can get. So we're gonna leave this for last. So we'll just solve for x. So what would I do to solve for x? Yeah, divide by 2. And that's when you go into the calculator and then plug this in. So, second E. So what do you guys get? 0.69. But probably big ideas round to 3 decimal places. So 0.69. 8. Yeah. 0.698.
If you put like 0.697 big ideas, then you have that wrong.
Probably if it
Probably.
says to round, yes. Usually it does.
Yeah.
If it doesn't say to round, then it should accept either. It should say 7 or 8 and accept either one.
Sorry. So what do you think? Too easy? Something slight? Or getting a little too complicated? It's just, honestly, it's just the same as solving for exponential equations. So, if we go on to number 3, this is my log isolated. Yeah. So we'll rewrite it as an exponential. So what is my base? 2. And what's it being raised to? It's being raised to 4. And that's going to be equal to what? So, unlike e to the 1/3, 2 to the 4th is actually going to give me a pretty number. So we'll just evaluate it right now. What's 2 to the 4th? 16? That's pretty nice too. So now we got a quadratic equation. You guys remember how to solve for x for quadratics? You would, Allie. Look at that. We're going to want to set the equation equal to 0. Minus 16.
You can do like, you can drop down the x squared derivative and multiply by 0.
Drop down to 2. So, whenever you're solving for quadratic equations, we do this little thing called factoring. You guys remember factoring? Yeah. So what shape do we use whenever we factor? Or it helps. Hmm?
Shape.
Hopscotch thing?
Yeah, use that hopscotch thing. Yeah. So we got
It's a few
a
rectangles.
yeah, we got a hopscotch. So what number is going to go on the top of the hopscotch? Yeah. And then in the bottom? Negative 15 squared? No. It's not negative 15 squared. It is going to be negative 2. Look at you. So now these two boxes, they're going to be two numbers. When multiplied together, give me a negative 15, and then added, they give me a negative 2. Negative 5 and 3. Negative 5 times 3, negative 15. Negative 5 plus 3, negative 2. Cool. So then we're going to go back. 0 is equal to. So what do I do with these two numbers here? Well, how does the factored equation look like?
X squared minus 5x.
Oh, okay. So like grouping? That's actually, that's smart. Yeah.
We did both ways when we did quadratics.
Cool. So, yeah, you can do grouping. So like there's going to be something like this. And since x is being squared over here, you can write 1x in the front and 1x right there. Because the x's are being squared. And then for whatever numbers you get, you'll put it into the parentheses. So if you got a negative 5, this one's going to be a negative 5. If you get a 3, since it's positive, it's going to be a plus 3. So now that I have, let's see, now that I factored the quadratic equation, what does my x have to equal in order for it to equal to 0?
Five and
5 and negative 3, yeah. 5 and negative 3. So normally we would be done, but since we have two possible answers for x, we have to plug them in to make sure we don't got an extraneous solution. So we can go plug in 5 in here, figure out what the log is, make sure it's equal to 4, then do the same thing with negative 3, but we can also use a calculator. So if you turn on your calculator, you're going to want to go to the y equals button. And for y1, you're going to put the log for y1. So go to math alpha math to get the log of the base. Log base 2 x squared minus 2x plus 1. And then for y2, you're going to put the 4. So the other side of the equation. And you get a 4. So once you got those, you're going to hit the graph button. And it's going to show you your y1 first, so that's the log function, and then the y equals 4. Yeah. So actually my window is a little messed up. Let me fix it.
Zoom 6.
Zoom 6. Yeah. There we go. That looks better. Yeah. So that's how it should look like. And then you'll notice that how many times are the graphs intersecting each other? Yeah, 2. So hopefully those 2 points, the x's are going to be 5 and -3. And the way you check it is you'll go to second trace. So do. And then go to number 5, which is intersect. And then you'll notice that there's a little star looking dude. So what you want to do is move it to one of the intersections. Because the calculator is going to tell you one intersection at a time. So we're going to start off with this one here. So once you get it close to the intersection, you're going to press enter again, and then press enter again. And it says that our x is equal to -3. So that's good. And then to find the intersection for the second one, you do the same thing. You go to second trace, you go to the intersect button, and then you're going to move the star all the way to the next intersection. And then press enter again 3 times. And then it says our x is equal to 5. So for this question, both of our x's are acceptable. Cool. So I know it's easy just going to the calculator. Yeah. But you know, we're gonna ask you to show your work. You can use the calculator just to make sure that you got the correct answers, but we kind of want to see you do this whole process here. Cool. So we move on to number 4. We got 2 logs that are being added to each other. So if you guys remember from 7.5, what can I do to these 2 logs in order to combine them into one? If they're being added. Was that true?
You just add them together.
Well, it would be a log, same with the same base, log 5. But since we're adding logs, we're going to want to multiply the arguments. So what would be my 2x squared times 8? What would that equal to? It would be 16x squared. That is equal to 2. And now that I have a log being equal to a number, what's my next step? Next step. What's my step 2?
You add 2 together, so then or subtract 2.
Oh, set is equal to 0?
Yeah.
But we have a log.
Yeah. Maybe the base and the log.
Distribute the base of the log. Well, what did we do for number 3? Whenever we had a log equal to a number.
You write it.
Yeah, we write it as the exponent. So how would I write log 5 16x squared equals 2 as an exponential?
2 equals
5 2 is equal to 16x squared. And what's 5 squared? 5. So now what do I have to do in order to get x by itself?
9 or x by itself.
Yeah, I want x by itself. And then, yeah, we have to divide by 16. And now we're left with 25 over 16 is equal to x squared. And how do I get rid of an x squared? You square root it. So x is going to be equal to the square root of 25 over 16. And what is the square root of 25 over 16? 1.25. Or, in other words, you take the square root of the numerator. So what's the square root of 25? 5. Yep. And then you take the square root of the denominator. 4. Which is equal to 1.25.
Did you leave it as a fraction, or did you have to write it?
You can leave it as a fraction if you want. Yeah. So, does the square root of 25 over 16 always equal to 5 over 4? Can it equal something else? So, if I do 5 over 4 squared, that gives me 25 over 16, right? Is there another number whenever it's squared that gives me a 25 over 16?
Not for a problem.
No?
No.
What if I add that negative right there? Is this still true? No? So a negative 5 over 4 times a negative 5 over 4.
That would be,
Yeah, that's positive. That's 16. And negative 5 over 4 squared, that is negative 5 over 4 times negative 5 over 4. So that is true. This is still true. So you're going to have to put that plus or minus here. So whenever you take the square root of a number, make sure that you add the plus or minus side. So now we're going to have to check these, a positive 5 over 4 and a negative 5 over 4, to make sure that there's no extraneous solutions. So we can go back to the calculator again, plug in or type the logs for y1 and then the 2 for y2. But the thing about logs is that your arguments, they always have to be positive. They can't be a negative. So if I plug in a 5 over 4 into this first log here, would I have a positive or a negative number? Negative? So positive 5 over 4. Is 5 over 4 squared? Would that give me a positive number? If I multiply it by 2, will I still get a positive number? Yeah, so 5 over 4 is good. If I plug in a negative 5 over 4, is a negative 5 over 4 squared? Is that negative? No, it's positive. And since it's positive and I multiply by 2, is it still positive? Yeah. Yeah. So for this one, the positive and the negative are going to be your answers, or they're acceptable. Since whenever you plug in each of them, you're not going to get a negative argument. So for number 5, we're actually not going to do this one. Well, we're going to do a different one. We're actually going to do log base 2x plus log base 2x minus 3 is equal to 2. So notice that you have two logs that are being added together. So what would my new log be? I wanted to combine them. Let's move on to log.
2 squared.
Well, what did we do with the logs for number 4? What did we do with the arguments?
Log 2 to the third. It should be 2 to the third, man.
2 to the third. Well, we want to combine these two logs into one. So it's going to be a log with a base of 2. And then I'm going to need a new argument since I'm adding these together. So what do I do with the two arguments that I have here? Did we add them for number 4?
Well, we multiply by times and then add one.
You would multiply them. So you would multiply that x with the x minus 3. So x minus 3. And that is equal to 2. And what can I do with these to simplify? Or what is x times x minus 3?
X squared plus 0 minus 3x.
So now that I have a log being equal to a number, I'll rewrite it as an exponent. So what's going to be my exponential? What's my base? 2. And that's being raised to the second. And that's equal to? Yeah. So now we have something that kind of looks like number 3. So this is 2 squared. What is that equal to? 4. So 4 is equal to x squared minus 3x. And now what do I have to do to this 4 in order to solve this quadratic equation? You got to move it over. And how do I move it over? Subtract 4 to both sides. So now you're left with 0 is equal to x squared minus 3x minus 4. So I'm going to do my hopscotch. So what number is going to go on top? 4 is going to be the negative 4. And what's going to go on the bottom? The negative 3, yeah. So now I need two numbers. We'll multiply together. Give me a negative 4, but when added, give me a negative 3. Negative 4 plus 1, let's go. Cool. So then I'll go here. 0 is equal to.
What's the symbol you put in the top box?
This one?
Yeah.
That's a negative 4.
Negative 4?
Yeah. Because that's what my C number is. It's a negative 4. And then a negative 3 because that's my middle number. It's a negative. So you're going to write x because you got your x squared, and then plug in the numbers that you got in your hopscotch. So minus 4 and the positive 1. So what are going to be my x values? Well, those are my hopscotch values. Well, we got negative 4 and 1 for,
X equals 4 and x equals 3.
yeah, x equals 4 and x. -1. So basically the opposite sign of your hopscotch values. So like -4 is 4, and then 1 is just -1. So now that we got those, we got more than 1. So we need to plug them then back into the equation to make sure we don't have an extraneous solution. So if I plug in a 4 into log 2, or plug in 4 for x, is my argument positive? If I'm plugging in a 4. If I plug in 4 for x, is my argument positive? For this first log here. Yeah, because x is your argument. So if you plug in a positive 4 in there, then you'll get a positive argument. If I plug in a 4 in for x for the x minus 3, what is 4 minus 3 equal to? 1. Is 1 positive? Yeah, so I got another positive argument. So 4 is going to be good. What if I plug in a -1 in for x? For log base 2x. Is my argument going to be positive? Nah. So since when you plug in a -1 and your argument is negative, this doesn't actually really exist. So since this doesn't exist, you can't add other stuff to it because, you know, it doesn't exist. So -1 is going to be an extraneous solution. So x is just going to equal to 4. Does that make sense? I guess good. Yeah. All right. So we got one more.
So my question is, with that 1, the -1,
Yep.
what happens to it? Just away?
Yeah, because if you plug it into the calculator,
Yeah.
so math off math, 2 to the -1, you're gonna get an error because it's a non-real answer.
Okay.
So number 6, we're not gonna do that. What we're gonna do instead is the ln x squared minus 4 minus ln x minus 2 is equal to 3. So for this one, I have two ln's or logs being subtracted. What would I do to combine these two logs into one? So like when we add them, we multiply the arguments, what will we do to the arguments if we're subtracting? So if we add, we multiply. Then if there's subtraction, we divide. Yeah. So you'll divide whatever the argument of your first log is, which is x squared minus 4, and then divided by the x minus 2. And that's equal to 3. So now that I have these ln's, or this ln equal to a number, I rewrite it as an exponential. So what is my base of an ln? What's the base of a natural log? Yeah. And what's it being raised to? Yes, being raised to the third. And then that's going to equal my argument, which is x squared minus 4. So if we look at this, the numerator, the x minus 4, can x squared minus 4 be divided by x minus 2? How? Well, what's so special about x squared minus 4 though? Yeah. How many terms are there in this quadratic? 3? I think there's 2. So you got the x squared, then you got the minus 4. So that's called that's a binomial. So if you guys remember how, say we want to factor this binomial, what would be the factored form of x squared minus 4? If we got a binomial. You don't remember this little flow chart over there, the factoring flow chart? So what kind of binomial is the x squared minus 4? Almost there, guys. What's the factor form of an x squared minus 4? You guys remember the difference of squares? Nah. So if you got a difference, so the x squared minus a number, so difference of squares is for a square number. Yeah. So what number squared gets me a 4? 2. So since this is the difference of squares, I can rewrite x squared minus 4 as an x plus 2 times an x minus 2. X plus 2. And that's being divided by x minus 2. So what can I do with these x minus 2s? Yeah. So then I'm just left with e to the third being equal to x plus 2. And now I just want to solve for x. So how do I solve for x here? Yeah. Move it by subtracting it by 2. So x is going to equal to e to the third minus 2. So you plug into the calculator, e to the third minus 2. And you should get 18.086 because they want 3 decimal points, so rounding 3 decimal points. So, long day today? Long day today? Yeah. Well, if you turn the page, we have these 8 questions. It's a mix of like log equations and exponential equations. Ooh, put them in there. So, number 5, what kind of equation is this? It's an exponential. What about number 2? What kind of equation is that? Cool, so you know which equations are which. That's great. So, if you guys have your foldables from last class, 1 through 8 are actually on the boards. I want y'all to get up, get a partner if you want, and then we'll solve 1 through 8 on the board.
Then if you want to copy them onto your notes after you finish, but we want to see them on the board.
So call up me or MikkiCastor to make sure you guys got the right answer,
So
and then continue on.
pick a problem, work it, call one of us over to check it. If it's good, then you'll move on to another problem and work that one. And I want us to do at least 3. I say at least 3 before we head out. Okay?
Wait, so we do it on the board?
We do it on the board.
Oh.
We want to make sure that what you're putting in your notes is right? So we're going to do it on the board first, and then one of us will check it, and then you guys can put it into your notes. All right, everybody grab a partner. It's better with a partner. Promise.
The markers and the little erasers are up here in the front, if there's not any on there.
That's straight up.
That's a long drive.
Bro, where at? I know. I moved out here from Chicago last year. Where at? Oh, you said it's from Roar. Yeah, and I introduced you guys.
I totally forgot. Last call. Brent and.
Yeah, they all call from Chicago.
They called Chicago.
Yeah, no one knows my name, actually.
That's right, because I asked Brent about you one day. I was like, so where's you at? Like,